Yes, for those of you who are at home, we are currently doing a survey in the classroom. So as soon as we get through the survey, we are gonna get started with the lecture. Thank you. Good. Thank you. Hey, good afternoon. Let's talk about facilities planning. So in our previous lecture, we were in lectures 10 part 1 and part 2, we're looking at designing conveyors, specifically these conveyors that have a carrier, and we were trying to define for one type of model, we're trying to determine the capacity of the carriers, and for the second type of model in which we were looking at the stochastic arrivals or the uncertainty in the arrivals, we were trying to determine for, again, say that same type of conveyor, the speed of the conveyor so we can reach steady state. So in this next lecture, we are now going to transition to designing the warehouse space. So in this first lecture, we have a couple of parts, 2 parts for this lecture. We're going to focus first on the information, and we're going to do some math. And also in the next lecture, we're going to talk more in terms of the actual design. So let's get started. This lecture is connected to the first objective of this course, which is to develop an understanding of the principles of facility location, layout, and material handling systems. This particular lecture is focusing on the warehouse of the facility. And the agenda for today, look at the introduction about this area of facilities planning, and then we're going to discuss the missions of warehouse, the functions in the warehouse, the receiving and shipping operations, and the storage operations in terms of planning the storage space. And the learning objective is to learn warehouse operations improvement through the application of best practice procedures and available material handling systems for warehousing operations. So again, we're going to be all this information that we've been discussing this week, past week, is all connected, right? You need some material handling equipment in order to move stuff in a warehouse. But now we're going to be focused on the product in terms of, okay, you have all this space. Where should you place this this product if you have this demand, for example? So if you want to have a product, or if you have a product that is moving a lot in terms of going in and out your facility or your warehouse, you want to make sure that you accommodate that product close to the door or the shipping door. But if you have a product that is not moving as often, then you can place that product maybe at far location from the door. And we're going to look at those type of models. So as an introduction, a renewed emphasis on the supply chain and customer satisfaction has increased the number of and variety of value-added services in the warehouse. I mean, if you're familiar with Amazon, obviously you see that there are multiple options now in terms of shipping, not only on the delivery speed, but also if you are sending a present, you have also the chance to make that look different. The package could be different for present and so on. So those are value-added services in the warehouse. The extra services might include kitting, special packaging, or label application. In our warehouse, resources include people, equipment, and space. So we are going to be dealing with these three mostly. People, the staff, the equipment, that includes the racks, also the material handling equipment, and the space, obviously. Unfortunately, such resources are often difficult to obtain and retain. The planning and management of today's warehousing operations are very challenging. Okay, so as we move forward with this type of environment in which we are trying to deliver value-added services to our customers, this planning and management of warehousing operations is becoming very challenging. Also, as we become more dependent on these type of services and things that can disrupt the supply chain can also create additional challenges, which we have seen and experienced during this pandemic. So what are the missions of the warehouse? The warehouse plays a critical role in supporting companies' supply chain success. Again, very important, not only being able to have the trucks and the routes and the optimal destinations planned, but you need to have a warehouse that is efficient in the sense of having the product in the right location, having the product that you need, and being efficient in the sense of loading and unloading these trucks. So the mission of a warehouse is to efficiently ship products in any configuration to the next step in the supply chain without damaging or altering the product's basic form. It's not only making sure that those products are in the right truck and their destination is correct, but also that this product is able to get to the final destination without being damaged. All warehousing opportunities, including order picking, cross-docking, productivity, space utilization, value-added services, allow the warehouse to process and ship orders more efficiently. So when I say order picking, these are these operations in which you, as I mentioned, for example, in an HEB, if you go to the warehouse here in San Marcos, that warehouse will be is in charge of supplying with product multiple supermarkets in the area. So a supermarket will be a client of this warehouse. Like for example, San Marcos here, the HEB close to the university will say, okay, I need more paper towel. Or I need this many, or I need this many, I don't know, soap. So they will get this order and they will assign this order to an operator, and he will be in charge of doing the order picking for the store in San Marcos. So he will put together the order and the shipment to, and then put it in the right location so he can reach the final destination. Anybody knows what cross-docking is? So cross-docking is a space, and I think we have several of those in I-35. You might confuse them with a warehouse, but they are not necessarily a warehouse. They will be like a centralized location in which trucks from different areas will arrive. They will put their products and then they will be reconfigured and then put back in different trucks. So it's like if you have a product that is just coming from El Paso, but you know that that product has to reach multiple cities in Texas, that truck will go to this cross-docking location and will separate the shipment, and then that shipment can be sent to multiple trucks in that location so that the product can reach multiple destinations. So that's the purpose of the cross-docking. Space utilization, we talk about value added. All of them allow the warehouse to process ship orders more efficiently. So the missions of a warehouse: improving order picking operations, Supply chain requirements today are driving warehousing operations to develop better order picking solutions. So again, this is the process of you putting together an order for your customer. At the high level, you're putting together an order for a store. The lower level, you might be putting together an order for a customer, like an Amazon customer. You're ordering multiple items and you need to put them all together in the same box. So those are the order picking operations. Utilizing cross-docking, the receiver typically requires the cross-dock goods to be sorted and pre-labeled. So this is the idea, as I was mentioning already. You have the supplier all bringing some type of product. Those are labeled or they have a specific color. And then you get to the cross-dock and you can separate those shipments and then place them in different trucks so they contain the right amount of product and different type of products that are needed by the customer. Number 3, increasing productivity is maximize the effective use of space, equipment, and labor. Okay, so as we were discussing one of our lectures already, you have a 2 machines and 1 operator, most likely one of those machines are going to be idle at some point. But if you have 3 operators and 2 machines, one of those operators might be idle at some point. So productivity is connected with that planning in which you're trying to maximize the effective use of space, equipment, and labor. Utilizing space, the old rule of thumb has always been that when a warehouse is more than 80% full, more space is needed. So you don't wait until the warehouse is 100% full. If you notice that you are reaching that level, then you know that you have to start planning for asking for more space. Increasing value-added services. Warehouse role has extended to include services that facilitate more efficient operations in the receiving warehouse, and therefore those should benefit the customer. The idea is again to gain some new customers or to keep the customers that we already have. So the old definition of a warehouse as just a place to store, reconfigure, and shorten lead times has become much more complex and technology driven. Okay, so not only an area for you to store items. Now you have all these value-added activities. You have all this technology that's allowing you to make better decisions, planning, scheduling, and so on. So warehousing opportunities within a logistic network are a lot. We have a lot. So for example, here we are trying to illustrate, we might have multiple manufacturers that can supply our warehouse. Or, I mean, that's if we are considering a separate facility as a warehouse. But sometimes the warehouse will be located close to the manufacturing, like in this case. We have alternative in terms of who wants to deliver or who is the most efficient, who has the most efficient route to deliver specific customer, or who has the product to deliver the right customer. Are we placing the product in the right location so we can serve our customers well, meaning that we are reducing the lead time and so on. So a lot of information being used to make these decisions and also to plan for reordering and so on. So now let's talk about the functions in the warehouse. There are many activities that occur as part of the process of getting material into and out of the warehouse. And here's a picture that shows the typical warehouse functions and flow. So we have the receiving, cross-docking, and shipping. So receiving, we have the direct put away to reserve. So this will be the area for reserve storage and pallet picking. And we also have the direct put away to primary. So in this case, we know this product will be moved really quick. So we don't necessarily have to put them in the reserve area. We can move it directly to the area where the cases or the boxes are created. So that's the replenishment area. And also we have the accumulation, sortation, packaging, and utilization, which is the previous steps to the shipping. So we have both alternatives. We have the receiving. This can go directly to cross-docking and shipment, or this receiving area can put away some of the stuff or most of the stuff into our warehouse facility in order to wait for the time in which we need to supply our customers. So in terms of the functions, we have the receiving, is the collection of activities involved in the orderly receipt of all materials coming into the warehouse, assuring that the quality and quantity of such materials are as ordered, and disbursing materials to storage or to other organizational functions that need them. Number two is the inspection and quality control. These are an extension of the receiving process and are done when suppliers are inconsistent in quality. So that's another challenge that you will face if you're in charge of these type of operations. Again, you're going to have multiple suppliers, multiple manufacturers that are going to be delivering product to you. So you have to make sure that they're sending you high quality product, because if not, that is going to be creating problems later on. So this inspection and quality control process is basically taking care of, especially those suppliers that are inconsistent in their delivering you good products. So quality control, I think if you are an industrial engineer, you have a quality control course. You're basically, it's impossible for you to inspect every single unit that is arriving to your warehouse, but you have some strategies like sampling, in which you're gonna go and get some samples from the shipments. And then those are gonna be designed in a way in which you can make sure that you're getting to identify the problem. So inspection and quality control is part of this function. Repackaging is performed in a warehouse when products are received in bulk from a supplier and subsequently packaged singly in merchandisable quantities or in combinations with other parts to form kits or assortments. So another part of the process. For instance, right now we are working with the state, actually with the city of Austin. We have a project in which we are evaluating the quality of some products that are packaged or produced by people with disabilities. So some of the things that they do is the repackaging of some of the products. And that involves putting together some of the different items that are produced elsewhere, or let's say they have can liners and they know that these X customers require this many units. So they would also develop those packages for, and these customers are offices or organizations in the state. So they serve mostly government and so on. And the idea is, again, you have an operation in this warehouse that is not necessarily a production, but a repackaging operation, and we evaluate their quality in that sense. So that's another function of the warehouse. And we have the put away, is the act of placing merchandise in storage. It includes material handling and placement. So Put away in the sense of we are not going to use it now, so let's put it in the warehouse and wait for an order for that particular product, and then we're going to use it. Number 5, storage is the physical containment of merchandise while it is awaiting a demand. Order picking, we talked about order picking already, is the process of removing items from storage to meet the specific demand. Sortation of batch picks into individual orders and accumulation of distributed picks into orders must be done when an order has more than one item and the accumulation is not done as the picks are made. So for instance, if you are an order picker and you're collecting products for multiple orders, 2 or 3 orders at the same time, then at the end you'll go and sort those products for the right orders. Packaging and shipping, checking orders for completeness and loading trucks. Cross-docking, inbound receipts from the receiving dock directly to the shipping dock. And the replenishing, this is primary picking locations for reserved storage locations. So 10 in total. You don't have to memorize all this. I mean, I'm not going to ask you to list all the functions in the warehouse. You just have to be familiar. So what is receiving, what is inspection and quality control, and repackaging? What is the difference between inspection and repackaging? Those type of things are relevant. Okay, so receiving and shipping operations. A key decision in designing the receiving and shipping functions is whether to centralize the 2 functions. As depicted in figure 3, the location of receiving and shipping depends on the access access to transportation facilities. So figure 3 shows the possible arrangements of shipping and receiving areas based on the access that you have in terms of, for example, a highway or a railroad. So at the top, you see the transportation facility is at the top of the warehouse. So you have multiple options when that's the case. You can put the receiving and shipping on the corners. Both have access to the transportation facility. This is the same, just with a different flow in the facility. So in this case, you can go from receiving to shipment and in this direction. Same thing here, just the flow is different. And in this, at the top, you have on the third one, has the receiving and shipments located in the same corner of the facility. So those decisions are based on, again, the location of the transportation or access to the transportation facility, and also in terms of what type of flow you want to have inside the facility. Here's some other, for B, we have transportation facilities on 2 adjacent sides of the building. So you not only have a transportation facility at the top, but also in one of the corners. Just like, for example, if you look at most of the Walgreens, that would be their case, or CVS pharmacies, they will always be located in a corner. So they have access from these 2 transportation facilities. So again, you have multiple options. If you look at the top and the location at the corners at the top, locations in one of the corners, and then you can also add this configuration in which you have the receiving and shipments on opposite sides. And then the transportation facilities on 2 opposite sides of the building. This gives you more flexibility. So now you are not constrained by only one side. You have access on both sides, or at least 2 sides of the building. So you can put them on the corners, opposite, Actually, you can also consider having them in the middle, which can benefit you in terms of moving equipment, moving product, because distances might be shorter if you have the doors in the middle of the facility. So those are different configuration, possible arrangements of the shipping and receiving areas. The following principles serve as guidelines for streamlining receiving operations. They're intended to simplify the flow of material through the receiving process and to ensure the minimum work is required. So number one states, don't receive. For some materials, the best receiving is not receiving or no receiving. Often, drop shipping, having the vendor ship to the customer directly can save time and labor associated with the receiving and shipping. So what this is saying is, if you can have your supplier deliver straight to your customer, like for example, again, I'll always go back to Amazon or eBay. We can all be suppliers for those type of businesses. You don't have to ship to their warehouse. If you sell something, you can directly sell or ship to the customer. So that's the idea. You're skipping that piece, you're saving space, saving money, and you're still getting some profit out of it. Pre-receive. The rationale for staging at the receiving dock, the most time and space intensive activity in the receiving function is often the need to hold the material for location assignment, product identification, and so on. Okay, so the rationale for staging at the receiving dock, the most time and space intensive activity in the receiving function is often the need to hold the material for location assignment, product identification, and so on. So that pre-receive principle means that if you are not sure that this product is gonna be moving often, or you cannot identify this product yet, you have this principle that says, okay, let's pre-receive. Let's make sure that we have the right information and we can place this in the right location in the warehouse. Cross-dock material, since the ultimate objective of the receiving activity is to prepare material for shipment of orders, the fastest, more productive receiving process is cross-docking. The simplest kind of cross-docking activity is one in which an entire inbound load is sorted and then reloaded onto one or more outbound vehicles. Okay, so simplest kind, that doesn't mean that it's gonna happen always, but if you have that type of operation in which you can assure you have a load coming in from a truck, and then you can split that and send it into other trucks for delivery, then that will be ideal. Complete all necessary steps for efficient load decomposition and movement at receiving. The most time we will ever have available to prepare a product for shipping is at the receiving. Again, making sure that we identify the product, check for quality, and we place that in the right location in the warehouse. That will save us a lot of time, save us a lot of trouble with our customers. And then when we get to the order picking process, we know where the product is, we know it's in good quality, it has good quality, and we can put together those orders quickly. Sort inbound materials for efficient put away. Inbound materials can be sorted to put away by warehouse zone and by location sequence. And we're gonna talk about that more in a few minutes. Balance the use of resources at receiving by scheduling carriers and shifting time-consuming receipts to off-peak hours. This is very important. So if you know that you have a product or a deliver that is going to take a long time for you to unload into your facility, you want to schedule those in off-peak hours, meaning that you avoid this truck, or you don't keep this truck for a long time in these doors, and avoid those other trucks to unload their materials quickly. Okay, so scheduling, which is one of our specialties as well as industrial engineers, using these optimization models to find optimal schedules, is very important for those purposes. I have also seen this, like for example, if you go to any city in the nation, let's say Austin, and if they have like a supermarket, I think they have a Whole Foods in downtown Austin, you can imagine they try to deliver their products on a peak time during the day. It will be impossible. So most of the time, they're scheduling these deliveries for the trucks at the time of the day in which they know they're not going to find any traffic in the city. So that's why you might not see them during the day. And that's not only in big cities, but anywhere where space is constrained, and also that you have a big volume of people that can create trouble. Number 7, minimize or eliminate walking by flowing inbound material past workstations. Bring the stock to an order picking station equipped with the aids and information to perform the necessary tasks. So, select the cost and space effective handling units. For loose cases, the option for unitizing loose cases include wood, disposable, returnable, and rentable pallets, plastic, metal, and nestable pallets. And for loose items, the options for unitizing loose items include totes and cardboard containers. In terms of another principle, minimize the product damage. Again, shipping principles, minimize the product's damage. Number 3 is to use storage racks to minimize floor space requirement for shipping staging. So you want to use not only the space in the floor, but also if you can go high and store some items using these racks, that's also good. Route on-site drivers through the site and minimize paperwork and time. And use small parcel shipment or shipping. That's relevant because you can easily manage small size items. You don't need as much equipment, and also the weight, it will be easier for managing. Storage operations, now talk about that. The objective of storage and warehousing functions is either to maximize resource utilization while satisfying customer requirements, or to maximize customer satisfaction subject to a resource constraint. So we talk about this a lot in operation research. You have a capacity limitation in terms of your resources. You want to make sure that you use those the best way possible so you can get the most profit, or you can produce the most items, or you can minimize your costs. So we can see this storage operation from 2 perspectives. We want to maximize our resource for keeping in mind the customer, or we want to maximize our customer satisfaction, knowing that we have a constraint in terms of the resources that we have available. And those resources are for warehousing, space, equipment, and personnel, or the staff. So in designing storage and warehousing systems, it is desirable to maximize all this: space, utilization, equipment utilization, labor utilization, material accessibility, and material protection. So this is a multi-objective type of problem. And you will imagine how difficult it is to make sure that we are moving in the right direction in which we all satisfy all these objectives. So there has to be some type of trade-off, and we know that. It will be based on what the company will value the most, or it will be based in terms of what will be more expensive. Okay, so if you know space is very expensive, you want to make sure that your objective or your decisions are guided to reducing the cost of your space. Or if your equipment is very expensive, you want to make sure that those machines or those material handling equipment are being used the most of the time, and you are not adding more equipment without planning very well. And same thing for labor utilization, material protection, and so on. So we get to this part, which is storage space planning. And here we go into identifying areas for locating our items. So a chart that can be used to facilitate the calculation of space requirements for storage and warehousing is the storage analysis chart. Okay, so what we have here is the for a company, GDS in this case, we have the description of the materials, the type, capacity, the size, the weight, the maximum, the average, in terms of how many you can storage, what is the average number of units that you have, how many have you planned, where are you gonna place them, the area that they will occupy, and the ceiling height required for those. So this is essentially putting together in a table all the information that you will need in terms of for the product, in terms of planning for the allocation of items in your warehouse facility. So there are two major material storage philosophies, and we're going to talk about those now. The first one is called the fixed or assigned location storage. And the second one is called the random and floating location storage. So both have their benefits and their disadvantages, and we're going to talk about those now. So in a fixed location storage, each individual stock keeping unit, or SKU, is stored in a specific location, and no other stock keeping unit may be stored there, even though the location may be empty. So you're basically assigning, it's like saying in this classroom, you have a student assigned to a chair or two, and then you can only sit there. If someone else comes and nobody's sitting in this table, nobody else can use that table. Okay, so we keep a fixed location for certain items. With the random and floating location storage, any SKU may be assigned to any available storage location. So there's no specific location for the items. An SKU stored in location A 1 month might be stored in location B the following month, and a different SKU stored in location A. Okay, so those are the main two philosophies for storage space planning: fixed location storage and random location storage. So which one do you think will occupy more space? Yes, fixed location. So the advantage of the random location storage is that you don't need as much space. So, but which one do you think will be more efficient in terms of picking orders and storing and so on? If you are an order picker and you have to put together an order, which one do you think will be better? Fixed location, right? Because you know that orders or the items will not change location. So if you are familiar with the location of the items, you know where to go to pick those items. So those are the advantages and disadvantages. One is more efficient in terms of space. The other one is more efficient in terms of the quickness in which you can put together the orders and you can set up your items in the warehouse. So the amount of space planned for an SKU is directly related to the method of assigning space. If fixed location storage is used, then a given SKU must be assigned sufficient space to store the maximum amount that will ever be on hand. Okay, so if we are using the fixed location storage, then we are planning, we know that for paper towel, we need the maximum that we're going to store is 100 units. Then we need to plan our warehouse to have that space for 100 units, which is the maximum that you would ever have. For random location storage, the quantity of items on hand at any time will be the average amount of each SKU. When the inventory level of one item is above average, another item will likely be below average. So you will have that behavior happening inside your warehouse, that your expectation is you have a high for one item, you have less for another item, and you will still have space to accommodate all your items. So the sum of the two items will be close to average. If a large safety stock of SKUs is maintained, then the quantity of items on hand at any time will be the safety stock plus 1/2 the maximum replenishment quantity of each individual SKU. Okay, so if a large safety stock or of SKUs is maintained, then the quantity of items on hand, instead of being the average at any time, will be the safety stock plus 1/2 the maximum replenishment quantity of each individual SKU. Okay, so let's look at that with an example. So in this example, we are trying to determine storage space requirement in number of loads. And we have a manufacturing firm. The average daily withdrawal rate for product A is 20 cartons per day. Safety stock is 5 days. Order lead time is 10 days. And the order quantity is 45 days. What are the maximum and average quantities of unit loads to be stored? Okay, so we have the withdrawal rate of 20 cartons per day. Safety stock is 5 days. Okay, so we have enough for covering the demand for 5 days. The order lead time, how long is it going to take for you to get those orders? And the order quantity is for 45 days. What are the maximum and average quantities of unit loads to be stored? So let's look at this from a production planning perspective. So we are going to compute the reorder point. Which is going to be equal to the safety stock in days times the demand per day plus the lead time in days times the demand per day. Okay, so the reorder point is telling us how many cartons we're gonna have in order to, we should have available when we are going to place the next order. So in this example, we have a safety stock of 5 days. So this is 5 days. Multiplied by the demand per day, which is 20 cartons a day, plus the lead time in days, is how long it's gonna take for us to get these units, times the demand per day, 20 a day. And this is equal to 300 units. So using this information, or the information that was given, we can also compute the maximum quantity to be stored. So the maximum to be stored that's going to be equal to the safety stock plus the order quantity so the safety stock is 5 days times 20 a day. And the order quantity will be the number of days for the order quantity, which is 45, times 20 units a day. So the maximum quantity to be stored will be 1,000 units, which is the safety stock plus the order quantity. That will be the maximum you will have at any point. If you have your all your safety stock in the warehouse plus your order quantity. The average quantity to be stored to be equal to 1/2 the order quantity plus the safety stock. Yes. No, it's just half of the order quantity. Yes, thank you. So the order quantity will be 900, right? Is 45 times 20. So this is 1/2 times 45 times 20 plus the safety stock, which is 100. And this is 550 units. So you can see the difference in terms of the number of units that you'll be required to store in the facility. If you are looking at, for example, fixed location and also a randomized type of storage. So let's look at the next. Yes. Yeah, that's additional. I just wanted to show you how to get the reorder point as well, but you don't have, I mean, to answer this question, you don't need that. Yeah. But you can see that for the reorder point, you also need the safety stock, which is here. And we need that for the maximum quantity to be stored. But good question. Yeah. And that also gives you an idea of how far you are from the reorder point. So in average storage, you have 550 on average units. So if you just drop 150 units, you know that you had to put another order, which is what the reorder point is telling us. So now we want to compare the randomized versus dedicated storage. Suppose that 6 products are received by a warehouse according to this schedule in table 1. So what we have here, we have time periods in this column, and these are products. Product 1, product 2, product 3, product 4, product 5, and product 6. And we are receiving these units every time period. So in time period 1, we get 24 units of product 1, 12 units of product 2, and so on. Time period 2, we receive 22 units of product 1, 2 units of product 6, and so on. In this column, what we have is the aggregate value, which is the sum of these numbers. So 24 plus 12 is 36, plus 2 is 38, plus 12 is 50, plus 11 is 61, and plus 12 is 73. So that's the aggregate value. And if we look at this table, we can identify multiple things. By summing the inventory levels of the 6 products, we get the aggregate inventory level, okay, which is what we have here in this column. With dedicated storage, the required space, as given in table 1, equals the sum of the maximum inventory level for each product. Okay, so remember, we're going to look at the maximum for each product, and we're going to plan for the maximum capacity for each product. So essentially, what we are doing for the dedicated storage is to go column by column for this. I mean, I'm doing this by hand, right? But typically you will have access to the computer, so you don't have to go and search for these numbers. So I'm gonna go through column for product 1. And I believe the maximum is 24. And then I go to the second column, and the maximum for the second product, I believe, is 36. For the next product, maximum is 8. Product 4, C24. For product 5, C24 again. And for product 6, it's 24 again. So if I'm not wrong, this should be the maximum for every column. So 24 plus 36 is 60, plus 8, 68, plus 24 is 92, plus 24 is 116, plus 24, that's 140. Okay, so for dedicated storage, the sum of those maximum for each product is gonna give us the capacity of what we need for the warehouse. And that's how we get this 140 pallets. So let me write that down. So we look for the maximum. So that will be 24, 36, 8, 24, 24, 24. And I know in some cases those numbers are repeated. That's fine. You just want to find the maximum. And then 24 plus 36 plus 8 plus 24, 24 plus 24 should be equal to 140, which is the maximum inventory level for each product, or 140 pallet positions. Now, with randomized storage, the required amount of space equals the maximum aggregate inventory level, or 105 pallets. So for the randomized storage, what we're gonna do is we're gonna look at this last column, and we are going to identify maximum aggregate inventory. So in that case, that will be 105 here. So the required amount of space for randomized storage will be 105. It is because at any point in time that, if you look at these 26 or 24 time periods, that's the maximum amount of items that you have through that period of time. So it's not because it's repeated, it's just because you're looking at each time period, right? And in this time period, you only have 73, 66, 51, 60, 105, right? So this one is telling you, okay, at this time period, I have gotten this many items in my warehouse, 105. So I need space for 105. And then you continue searching, and there's no other time period in which you're gonna go above that, right? So at that point, you have identified for any day based on this history data, the maximum number of items that you will see in your warehouse is 105 based on this historical data. Okay, it's a combination of items, but in total, the maximum number of pallets is what we're dealing with here is 105. So in this example, dedicated storage requires 1/3 more pallets positions than does randomized storage. To maximize throughput, when using dedicated storage, SKUs should be assigned to storage locations based on the ratio of their activity to their number of openings or slots assigned to the SKU. Okay, so going back to dedicated storage, we have all this space now. Want to know where to place these items in this space, and obviously we're going to have some type of metric to make those accommodations. The metric is based on the ratio of their activity, the number of openings or slots assigned to the SKU. The SKU having the highest ranking is assigned to the preferred openings, and so on, with the lowest ranking SKU being assigned to the least preferred openings. Because fast movers are up front and slow movers are in the back, throughput should be maximized. If you only have to go and pick these items that are on the back twice a month, then you don't have those in the front occupying space. Just have to go get them when you need them. Excuse me, but if you have a product that is moving a lot of times during the week, you want to keep those close so you can move them faster. So in ranking SKUs, it is important to define activity as the number of storage retrievals per unit time, not the quantity of materials moved. Despite the greater throughput of dedicated storage, it is not used as often as it should be. One reason is that it requires more information to plan the system for maximum efficiency. When conditions change significantly, items must be relocated to achieve the benefit of dedicated storage. Hence, randomized storage is more appropriately used under highly seasonal and dynamic conditions. For example, if you are a supplier for decorations, you know that those are going to be changing depending on the season. So randomized storage might be a better strategy for you, because some point you have Christmas decorations, some point you're going to have Halloween decorations, San Valentin decorations, and so on, summer decorations, and so on. So for highly seasonal and dynamic conditions, randomized storage will be more appropriate. When many SKUs exist, dedicated storage based on each SKU may not be practical. If you have 1 million products, then it will be very difficult to plan for every single one of them. Instead, SKUs can be assigned to classes based on their activity to space ratio. Class-based dedicated storage with randomized storage within the class can yield the throughput benefit of dedicated SKU storage and the space benefit of randomized SKU storage. So that alternative is a mix of both philosophies. Depending on the activity to space ratio, 3 to 5 classes may be defined. So for example, here we have a turnover-based storage and its impact on throughput. Suppose the storage area for the warehouse is designed as shown in figure 5. A single input-output point serves the storage area. So we have that dock here. All movement is in full pallet quantities. The storage area is subdivided in 10 by 10 storage space. 3 classes of products, A, B, C, will be stored. And we have the description for each item on this box. So class A items represent 80% of the input-output activity and have a dedicated storage requirement of 40 storage space, or 20% of the total storage. Class B items generate 15% of the input-output activity and have a dedicated storage requirement of 30% of the total, or 60 storage space. And finally, class C items account for only 5% of the throughput for the system, but represent 50% of the storage required. So assuming that a lift truck travel between the input-output point and individual storage space can be approximately by rectilinear distances between the dock and the center of each bay. The distances are shown in this figure. So you see, you are close to the dock. Right? You have a small distance. And as you move farther from the dock, your distances are increasing. So those positions with the smallest distance should be used for those products that are moving faster. But as we mentioned in the previous slide, instead of just focusing on individual products now, we want to group them. And we want our warehouse to be split it in 3 to 5 areas so we can use the benefits of both the dedicated storage and randomized storage. So based on the ratio of input-output activity to dedicated storage requirement, the product classes will be placed in the layout in the rank order A, B, and C to obtain the product layout. The expected average distance traveled for the dedicated storage layout shown in figure 7 is 53.15. So you see, we are basically separating this area for product type A, this area for product type B, and this area for product type Z. C has the maximum space, but since it is moving at the lower rate, we can place it on the back of the warehouse. If randomized storage is used such that each bay is equally likely to be used for storage, then the expected average distance travel will be 100 feet. However, with randomized storage, the total storage requirement of less than 200 bays is anticipated for the reasons discussed previously. The exact storage requirement will depend on the demand and the replenishment patterns for the 3 product classes. Even though the storage requirement for randomized storage is not known, it is possible to compute an upper bound for storage. It yields an expected distance travel equal to or less than the one for dedicated storage. To do this, storage bays are eliminated from consideration in reverse order of their distances from the input-output point, and the expected distance values are computed. Process continues until a sufficient number has been eliminated. For the example, 138 storage bays or 69% must be eliminated for randomized storage to yield an expected distance travel equal to 52.90 feet. Okay, so that will be the last slide for this lecture. We will continue our discussion on Monday. So we are just getting started with the warehouse design. We have another lecture coming, and the assignment I think is already posted, so you can look at that online. And let me know if you have questions.
Dr. Perez, I have a question about the homework.
Yes.
Okay.
So I'm going to stop recording.